Now, for the reactions of aromatic hydrocarbons, okay, so the aromatic benzene ring, the aromatic ring system of benzene remains intact in nearly all its reactions. Okay, so intact pa rin daw yung benzene ring. There is no addition reaction. Remember that when we say addition reaction, katulad nung sa reaction of alkene and alkyne, wherein pag mag-a-add ka, if that's an addition reaction, say for example, you have here carbon to carbon double bond. If say for example, you're going to add bromine, what happens there is the double bond will be broken so that you could add the the substances being added or the atoms being added to it. Okay? So, ang nangyayari dun sa past na diniscuss natin na reactions, the site of reaction is the double bond or the triple bond. Nabre-break yan para maka-accommodate sila ng atoms, either halogens or the water molecules or the hydrogens. But for the case of aromatic or benzene rings, even for a fact na meron siyang double bond, okay, kasi nga ang kanyang structure ay alternating double bonds, hindi ibig sabihin na they will follow the reactions just like with the alkene. Okay, so ulitin natin, no addition reaction. Walang magbe-break dun sa double bond ng benzene ring. Kaya nga sabi dito sa first sentence, the aromatic ring remains intact. The benzene ring remains intact kasi hindi natin i-break yung double bond sa benzene ring. That's why it will not undergo addition reaction. Okay, no addition reaction. Rather, ano bang meron dito? It would just be a substitution reaction or precisely electrophilic aromatic substitution reaction. Pag sinabing substitution reaction, nagsasubstitute lang. Okay? So, one or more hydrogen atoms in the ring will be replaced by the group of atoms being added or being added to the benzene ring. Okay? So, makikita natin mamaya. But what includes this substitution reaction? It could either be nitration, reaction with nitrates, halogenation, reaction with halogens such as chlorine and bromine, sulfonation, of course, with the sulfur, and Friedel-Crafts alkylation. So, ulitin natin, alkyl groups, yung mga methyl, ethyl, okay, so yun ang maidadagdag dun sa benzene ring. Okay? And we have to take note that for substitution reaction or electrophilic aromatic substitution reaction, the benzene ring serves as the source of electron. Pag sinabi nating source of electron, or more likely, they are the electron donor, they are considered to be the base, and whatever they react to would be electron acceptor. Pag sinabi nating electron acceptor, kulang sila or they are deficient in electrons. That's why they want to accept electrons. And usually, these are electrophilic reagents or they are acids. Okay? So, ulitin natin, by definition, the bases are the source of electron, they are electron donor, and the acids or electrophilic reagents are the electron acceptors or they are the ones deficient in electrons. So sa kanila ibibigay yung electrons na galing kay base kasi nga siya ang source of electron. Okay, so let's have the first electrophilic aromatic substitution reaction. Let's have nitration. Nitration happens when one or more of the atoms or hydrogen atoms on the benzene ring is replaced by a nitro. Anong source ng nitro group? Nitro is NO2. Okay? The source of nitro in the nitration reaction is actually an acid. So this is nitric acid. Nitric acid is HNO3. Okay? So, nirearrange ko lang HONO2. H, ayan pa rin naman yung H, N isang N, tapos yung O2, ay yung O3, pinaghiwalay ko yung isang O para mas makita natin yung mechanism ng reaction. Okay, so but nevertheless, this HONO2 is just the nitric acid na HNO3. Tatandaan, itong HONO2 is just the HNO3, nitric acid. Okay, so mechanism, walang mabre-break na double bond sa benzene ring. Rather, kasi yung pag-break ng mga double bonds at triple bond is for addition reaction. Since hindi natin i-accommodate ang addition reaction, rather substitution, magsasubstitute lang tayo. Okay? So, pili tayo ng isang hydrogen. So, one hydrogen from the benzene ring, makikipagpalit daw siya. So, papalitan siya since this is nitration, kukunin natin yung NO2. So, magpapalit lang sila. So, the place of hydrogen will be taken by the nitro group. And, of course, the place of the nitro group in the nitric acid will be replaced by hydrogen. This reaction will only take place, or this is only possible if there is a substance known as catalyst and in the form of sulfuric acid, H2SO4. Ulitin ko, catalyst are substances that enhances or hasten or make the reaction faster so that magpupush through yung reaction. Kung walang sulfuric acid na nakasulat dito, of course, walang product na maproproduce. Wala itong dalawang ito. So, very, very important ang ating catalyst. Okay? So, going back, ayun nga, sabi ko kanina, yung NO2, magpapalit lang sila ng hydrogen dun sa benzene ring. Kaya, eto, na-attach na si NO2 dito sa ating benzene ring. And from benzene reacting with nitric acid, ang in the presence of sulfuric acid, of course, ang maproproduce natin is a nitrobenzene. Okay. A side product will also be produced in the form of water. Paano nagkaroon ng water dito? Remember that from the nitric acid, the NO2 part has been replaced or substituted by the hydrogen from the benzene ring, kaya meron tayong HOH. Kasi nagpalitan nga sila. Nag-swap sila or nag-substitute. Okay? So, ulitin natin for any nitration reaction, okay, for any nitration reaction of a benzene ring or of any aromatic compounds, it will react always with the nitric acid, wherein the nitro group NO2 coming from the nitric acid will be replacing the hydrogen from the benzene ring. And this will only happen if there's a catalyst in the form of sulfuric acid, and if all of these reactants and catalysts are present, the products that we're going to form are the nitrobenzene, so meron ng nitrogen, and a side product of water, HOH, or collectively known as H2O. Okay? So let's have, okay. So ayun nga, yung ating sulfuric acid kanina, H2SO4, okay, that serves as a catalyst, is the one that protonates the nitric acid to form the nitronium ion and the loss of water molecules. Okay, so this nitronium ion is very good electrophile and is open to attack the benzene ring. Kaya siya na-attach dito sa benzene dito. Okay, so still, ito yung sinasabi ko kanina. So, we have the benzene with the nitric acid, HNO3. And the presence of the catalyst, we're going to have the nitrobenzene and the side product of water. Okay. Paano naman kung hindi naman siya simpleng benzene at marami siyang substituent? Like this one. So, you have toluene. You now have the original substituent. So, may original substituent siya, ha? Kanina kasi yung diniscuss natin, plain lang na benzene. Paano kapag may mga substituent na yan? Of course, the substituent will remain intact. Kasi nga, ang mechanism naman ng nitration ay excuse me, hydrogen lang ang sinasubstitutan niya. Okay, so any of the hydrogen, so let's have the hydrogen on the second carbon atom. So the nitro group will go there, and the hydrogen, of course, will replace the nitro in the nitric acid. So we're going to have the ortho-nitrotoluene. Ulitin natin paano naging toluene at bakit wala ng benzene ring dito. Kasi ang priority ng naming ay si benzene ring with CH3, and of course that is collectively known as the toluene. At yung hindi pa nasama ng nitro, ito yung pangalan niya. Bakit O? That represents ortho for carbon 1 and 2 designations. Of course, hindi natin kalilimutan yung water molecules na maproproduce from the reaction of hydrogen and the OH coming from the nitric acid. Okay, now Second reaction is the sulfonation. Sulfonation reaction is the replacement of, again, hydrogen. So hydrogen atom will be replaced by this time with the sulfonic acid, SO3H. Okay? Kung kanina nitric acid yung ka-reaction ng benzene, the mechanism here is itong OH, SO3H is known as the sulfuric acid. Okay, so this is sulfuric acid H2, sorry. So this is reacting with sulfuric acid H2SO4. Pero disarrange lang natin para makita natin yung mechanism kung alin sa mga atoms or mga atoms na nasa sulfuric acid ang magre-react with the benzene ring. So, pero parehas pa rin naman to sila. H2SO4. Okay? So, mechanism is, so the sulfonic acid, SO3H, will replace or substitute hydrogen from the benzene ring. Of course, again, meron tayong substance dito sa taas ng ating arrow. Ang tawag dyan ay catalyst. The catalyst for this case is sulfur trioxide. Okay? Again, catalyst, i-enhance niya, i-hasten niya yung reaction para mag-push through. Kung wala siya, of course, hindi magpupush through yung reaction. Ang maproproduce dito ay benzene, sulfonic acid, kasi nga yung hydrogen has been replaced by the sulfonic acid. So, we have benzene, sulfonic acid, and of course, another side product, water, kasi nga yung hydrogen naka-react siya sa OH. Okay? So, the sulfur in the sulfur trioxide is electrophilic. So, the benzene attacks the sulfur and the subsequent proton transfer occur to produce the benzene sulfonic acid. Okay? So, ulitin natin, benzene ring reacting with sulfuric acid, but the sulfonic acid part only goes to the, or rather replaces the hydrogen in the benzene ring with the presence of sulfur trioxide to produce benzene, sulfonic acid, and water. Okay, paano kapag hindi naman siya plain na benzene? Okay, kung may mga substituent siya, ulitin natin, mare-retain pa rin yung original na substituent dyan. Okay, so reacting with sulfuric acid and the catalyst sulfur trioxide. So may hydrogen dyan, pwedeng pumunta dyan yung sulfonic acid part. And of course, the hydrogen will react with the hydroxyl or the OH in the sulfuric acid. So we're going to produce water. So again, toluene, sulfonic acid. Okay? Sulfonic acid lang kasi ito. Bakit na-retain pa rin yung toluene? Kasi yung toluene, ito yung dalawa niyan. Tapos ito yung sulfonic acid part. Parang dito lang din. Okay? The benzene is the ring and the sulfonic acid part is the SO3H. And remember, the attachment is in the sulfur.